So hello guys, once again I welcome here all of you in this marathon session of environmental engineering. Today we're gonna cover quality of water, and in previous lectures we covered the water demand and source of water and its conveyance, and today we're gonna cover quality of water. Okay, so let's start from that quality of water, or you say quality of raw water. Okay, in this first thing that chemical water quality parameter. So chemical water quality parameter. Yeah, so in this first thing is total dissolved solid, or you say TDS. For this we have value limit that from 500, and we have a limit of 500 for acceptance, and cause for rejection its value is, and 2000 for rejection. Okay, this is TDS, total dissolved solid. And in this one more thing, that electrical conductivity at one more thing, that electrical conductivity at 25 degrees Celsius, electrical conductivity at 25 degrees Celsius. Basically this is in mu mole cent per centimeter. Okay, into 0.65, then you'll get a dissolved solid content. This is equal to dissolved solid content. Okay, and for if we talk about TDS, the major source of TDS major source of TDS is uh, two or three things, that Na plus Ca Mg CO3 minus, so 42 minus Cl minus, 42 minus and Cl minus. These are the major source of total dissolved solid, and our minor source of TDS is that minor source of TDS. It is lot FeK CO3 2 minus, NO3 minus, and fluorides, boron, silica also, fluorides, boron and silica. Okay, so this is all about total dissolved solid. Let's move on to next thing, that alkalinity. Alkalinity. In alkalinity, we talk about major and minor compounds. So in this major compounds, are CO3 2 minus, SCO3 minus, and OH minus. So CO3 2 minus, HCO3 minus, and OH minus. Do remember these major sources, major and minor sources, because it will help you a lot to solve numericals. Because you in numericals there you need to you need to identify whether that parts, that compounds of alkalinity and compounds of total dissolved solid. Okay, there are bunch of chemical things given there, and you need to identify that what in these which are from the chemical compounds and which are from the for total dissolved solid. Okay, so you need to remember that which are came into the compounds of alkalinity and in total dissolved solid, and we'll see it next thing also. Okay, so here in minor compounds, that HSiO3 minus H2BO3 minus HPO4 2 minus H2PO4 minus H2PO4 minus and HS minus. Okay, so this is our major compounds and minor compounds of alkalinity. Major compounds, that CO3 2 minus SCO3 minus OH minus. Minor compound are HSiO3 minus H2BO3 minus HPO4 2 minus H2PO4 minus and HS minus. Okay, these are alkalinity's major and minor compound. And in alkalinity, the concentration of substance A can be expressed as an equivalent concentration of substrate B. This is a very important thing in quality of water numeric part, that this will this the whole numericals of quality water quality is depend on this thing, which I'm gonna write. Okay, so that this is very important. Make it as note that the concentration of substance A, the concentration of substance A can be expressed can be expressed as an equivalent of as an equivalent concentration of another substance B. Okay, do remember this concept. This will help you a lot. So in numeric type of thing, if we say this, then we can also say it like that by L of A to the G equivalent of A into G equivalent of B can be expressed as, then this is equal to G of A, wait a second, by L G per liter of A expressed as B. Okay, so this thing is written in mathematical form. Okay, so yeah, if we talk about total alkalinity, then total alkalinity means, if we talk about total alkalinity, total alkalinity, where in here we need to find that OH minus, alkalinity due to OH minus, SCO minus and CO3 2 minus, and this total alkalinity is neutralized neutralized at neutralized at pH of 4.5. Okay, remember this point, that this total alkalinity is neutralized at pH of 4.5. Okay, so this is it. This is all about alkalinity. And one more thing, that some kind of table you say, and that if let's discuss it in next page, that before draw the table, let's see, remember that mole is equal to weight in gram upon molecular mass. Obviously, mm, you guys know it, that mole is equal to weight in gram upon molecular mass. So let's discuss that table. If we have a P is equal to M, then it is, you say, caustic alkalinity. Okay, is caustic alkalinity. Caustic alkalinity. And if P is equal to m by 2, it's carbonate alkalinity. Carbonate alkalinity. And if P is equal to 0, then all alkalinity is CO3 minus. It is HCO3 minus. Okay, and if P less than m by 2, then predominate species are CO3 2 minus and HCO3 minus. And if P greater than m by 2, then predominate species are OH minus and OH minus and CO3 2 minus. So if if P less than m by 2, then predominate predominant species are CO3 2 minus and HCO3 minus. Okay, and if P greater than m by 2, then predominant species are OH minus and CO3 2 minus. Okay, so this is a table, and from this table, from pH of 4.5, we also have a graph there. This from, wait a second, where is it? Oh, this is in next, in previous page. For this thing, pH 4.5, we also have a graph there that something like, wait a second, that if we draw that graph, you'll also solve by using this, solve numericals by using this graph, or you also solve by using your formulas. And this graph is basically related as from these table. Okay, so let's draw it here. So let's draw it here. Something like this. And here this is pH 4.5. Okay, it is ml of titrant, and we have a graph something like this here. And another one is one shit, man. Okay, and this here is our P, this here is M, and this here half CO3 2 minus plus SCO3 minus. Okay, and here OH minus plus CO minus plus CO3 2 minus. Okay, so this is it in this graph, and here its value, it is 4.5 and it is 8.3. So this is it in this graph. Now you will easily relate this graph with with these table. Okay, now you usually relate this graph. Okay, that if P is equal to M, that if this P is equal to M, this both are equal, then it is caustic alkalinity. And if P is equal to M by 2, then this is carbonate alkalinity. If P is equal to 0, then all alkalinity is due to HCO3 minus. And if P is less than M by 2, then predominant species are CO3 2 minus and HCO3 minus. And if P is greater than M by 2, then predominant species are OH minus and CO3 2 minus. Okay, P is greater than M by 2, like this graph is somewhere here, and P is less than M by 2 somewhere here. Okay, so yeah, this is it about alkalinity. Let's move on to next thing, that pH. What? pH. pH, basically all we know that the pH have a formula that minus log H plus to the base 10 mole per liter. Mole per liter. On the formula point of view, we have only this much in pH, but if we talk about the numerical things, there are a lot of numericals in gate examination from pH and alkalinity. So if very soon we'll cover previous year questions of quality of water, then there we'll see that how much questions and which type of questions from pH and from alkalinity there in a gate examination. Okay, otherwise there's a lot of question from pH, and there is a very good question from pH. Okay, because if you submerge, if you know, if you add both topics of alkalinity, pH and hardness, you'll get a very good question in gate examination of about 2 marks. Okay, so yeah, let's move on another thing, that is hardness. Hardness. Okay, basically in hardness we have two things, that carbonate hardness and non-carbonate hardness. That yeah, carbonate hardness and non-carbonate hardness. Come on, this line, yeah, yeah, no, it's perfect. That carbonate hardness and non-carbonate hardness. For carbonate hardness, we also tell carbonate hardness as a temporary hardness. Temporary hardness. And non-carbonate hardness, we also say it is as permanent hardness. Permanent hardness. Okay. In this, we have in this and in this we have, yeah, in this we have a CO3 2 minus or HCO3 minus, CO3 2 minus and SCO3 minus of Ca2 plus and Mg2 plus. Mg2 plus. Okay, and in this we have Cl minus, we have SO4 2 minus and NO3 minus of NO3 minus, NO3 minus of Ca2 plus and Mg2 plus. Okay, so this is about carbonate hardness and non-carbonate hardness. For hardness, our minor sources. Let's just discuss about for carbonate. Our minor sources Fe2 plus, Mn2 plus, Sr2 plus, and you know Al3 plus. Our minor source Fe2 plus, Mn2 plus, Fe2 plus, Mn2 plus, Sr2 plus, and Al3 plus. Okay, and for total hardness, we have a limit for total hardness. That for total hardness, we have limit of 300 milligram per liter, and for rejection we have limit of and for rejection we have 600 milligram per liter for rejection. Okay, so yeah, this is about the total hardness. For calculation of total calculation point of view of total hardness, we have formula that let's say total hardness is equal to the formula Ca2 plus in milligram per liter upon equivalent weight of Ca2 plus equivalent weight of Ca2 plus into equivalent weight of CaCO3. This plus same thing for magnesium, that Mg2 plus in milligram per liter upon equivalent weight of Mg2 plus equivalent weight of Mg2 plus multiplied with equivalent weight of CaCO3, equivalent weight of CaCO3. Okay, this formula for calculating total hardness. And we have one more formula for calculating total hardness. You say you one more modified formula to calculate total hardness, that total hardness is equal to um, one more formula also, that total hardness is equal to Ca2 plus in milligram per liter into combining weight of CaCO3 into combining weight of CaCO3 to the combined weight of Ca2 plus, combining weight of Ca2 plus. Okay, this one, and same thing for Mg2 plus, that Mg2 plus in milligram per liter into combining weight of combining weight of CaCO3 give me a second, combining weight of CO3 to the combining weight of Mg2 plus. Weight of Mg2 plus. So this is one more formula. Shit. One more formula to find total hardness. Yeah, these two formulas to find total hardness. Okay, and for calculating carbonate hardness, if you need a carbonate hardness, so for carbonate hardness, you need to find total hardness and alkalinity, and whichever is minimum from both of these, whichever is minimum is equal to carbonate hardness. Okay, so this is about hardness. And if you get a carbonate hardness, subtract it with total hardness, you'll get non-carbonate hardness. Okay, and one last thing in quality of water, that most probable number, most probable number. We have one formula for this, that Ampian number. This is basic formula, number of positive tube into 100. Shit, man. Wait. Number of positive tube into 100 upon in under root upon sample upon milliliter sample in negative tube, sample in negative tube multiplied with milliliter sample in all tubes, milliliter sample in all tube. Okay, so this is a formula for Ampian number. Basically, there's a if in numericals there is a table where you give the values of positive tubes, negative tubes, and all tubes, and from that table you need to find that values and put it there, and you will get the most probable number. And there is also a concept in most probable number. If you go with the theoretical part of most probable number, then you will get that concept, and there is a lot of question which is relied on that concept, otherwise which is not gonna solve with this formula. So for that you need to learn those concepts from your books or whichever material you want to prefer. Okay, so this is it. This is all about in quality of water. This is it for today. And yeah, still then do a lot of more question for gate examination. And yeah, take care of yourself. And thank you so much for watching this video. Thank you guys. Thank you so much for watching this video.